Hello, welcome to another brief edition of AC with Wacy. This one shouldn't take long. I've had a couple of contractors ask me to do one on this just because we end up, when we talk to homeowners about the size of a system and ductwork and all of that, one of the major factors that we'll talk about is static pressure, and most homeowners have no idea what static pressure is. And I guess this video is more or less meant to kind of inform you about what it is so that you kind of get an idea of what it is and why it's important. So static pressure is more or less resistance to airflow on your system. If you have, say, a 3-ton system, most 3-ton units, the airflow is supposed to be around 1200 CFM. To get that full 1200 CFM, your static pressure needs to be set within the manufacturer specs. Most manufacturers test their units at 0.5 inches of water column. A lot more of the newer high efficiency stuff, they're going lower than that. So it's important to know what unit you're putting on and what your ductwork is to control the static pressure. Some of the things that you'll have happen if you have static pressure that's wrong, you'll have a very noisy system. The air being pulled in will be really loud. If your ductwork is designed right and your static pressure is where it's supposed to be, you shouldn't have an overly loud system. You're going to hear it run if it's in the attic or in a closet. I mean, you're going to hear it run. But if it sounds like a jet taking off, you probably have a static pressure problem. So basically what we have is we have a force exerting air out of the blower, and then there's resistance to that force, and if the resistance to the force is too high, it can't operate properly to get enough of the air out. Some things that are common, I guess, that cause high static pressure. If you have dirty filters, it ups the static pressure. I find that water's a good analogy for a lot of people when it comes to air and airflow. It's hard to picture airflow being resisted. But most of us have worked with a garden hose or a water pipe or whatever, and you block the end of the hose or you do something to restrict that water flow, and it sprays out harder. It sprays out harder than if it's not restricted, I guess. And that's basically what's happening inside your AC system, is it builds up pressure. And there's a certain amount of pressure that we want to make sure that the air blows across the room. But when that pressure gets too high, it makes it to where the heat exchange happening inside of your unit is hurt and basically does less than it should. It's also hard on electrical parts. If you have a motor that is running on a system with high static pressure, that motor is under more pressure. The internal workings of the motor will heat up more, cause more amp draw. Your Freon is trying to flow through your unit at a kind of a controlled rate, so that it can change from liquid to gas throughout your system as it needs to release pressure or release temperature and gain temperature. So a high static pressure will make that air move faster through your coil and cause less heat exchange, or you won't get enough air across the coil and you'll end up freezing your coil. Most of us have had a system freeze up or dealt with a system that's freezing up. A lot of the time, it can be caused by Freon as well, but a lot of the time it's an indication of static pressure problems. Your filter is dirty, your coil is dirty, your blower wheel is dirty, or your blower motor is not running at the correct speed. Bad ductwork design can cause it, but the main thing on ductwork design that causes it is improper return, which is where the air is pulling in. If you don't have a big enough return to pull the volume of air that you need, it makes it go through a higher velocity coming through there, and sometimes can't pull it through there at all. So when your system's overly loud, it's a good indication that you have a static pressure problem. Uh, Basically, the more resistance you have through there, the louder that motor is going to be. The faster the air is moving, the louder the air blowing out is going to be, or pulling in. Um, some real common things that you'll run across is a dirty filter, or a coil that has gotten dirty from the filter not being changed enough, or a gap in the system pulling in dust or whatever. Your coil's running, and because it's exchanging heat, that coil is usually sweating, which means it's wet. If you pull dirt up on that, it's going to stop on your coil, and it's going to build up over time. And then the other thing that you run into quite a bit, just because of poor design, is not having enough return on a system. Uh, there's there's a lot that goes into sizing returns. You need the correct grill face size. That's what you see as a homeowner in your home. But you also need the correct ductwork going from that grill back to the unit. And ductwork itself has resistance in it, depending on the type of ductwork. Say metal duct, it's rigid, it's smooth, air flows through it a lot better. There's a minimal resistance on that air flowing through there. It's basically rolling through the pipe, and it's good until it hits the grill, and the grill provides some resistance, the filter provides some resistance, the coil provides some resistance. A dirty blower wheel can cause some resistance. But if you use flexible duct, like most of our area does, most residential around here, flex duct can cause a lot of resistance if it's not installed properly, if it's really loose, or there's a lot of turns in it, or it's just sort of wavy on the hangers. Different things like that. Every turn in that duct will add a little bit of resistance to it. A sharper turn will add a lot of resistance to it. So the duct design is important, but the duct installation is also very important. So if you have a system that's overly loud, or you're getting kind of dirty grills and stuff on the end, a system with high static pressure, you'll see mold and stuff build on the grills sometimes, and that's because either that air is so cold when it gets there that it reacting with the warm air in the room causes the grill to sweat, or it's just such a dense air as it comes out that it gives it somewhere for stuff to build up. So if you have issues with that type of thing, or your system's overly loud, or you're freezing up, or you have hot and cold spots in your house, one room's hot, all the rest are cold, or it doesn't stay consistent, it's kind of feels like you have enough air sometimes and not enough air other times, you probably need to look at your duct installation, your duct design, and make sure that you're not causing high static pressure through your system, damaging your motors, and affecting your freon flow, which affects your compressor, and all of that stuff. You'll get higher bills, higher energy bills, if you have static pressure problems, just because the unit can't operate as it's designed. It's getting a lot more resistance, the heat exchange is a lot less, you're pulling more amp draw because your motors are hot, your compressor's flashing and getting hot. So if you have a combination of these issues, or one of these issues, you probably need someone to look at it and make sure that they take a static pressure reading. Static pressure reading is very simple to do. most AC guys should have a manometer on their truck to measure the pressure on one side and the pressure on the other side, and then you can subtract them and basically find your system static pressure. All air handlers will be stamped with a factory recommended static pressure. So if you take that test and it's outside of that range and too high, you need to add duct or fix a resistance problem in your system, and then you'll be back to operating normally. But I would suggest if you've got any issues, call your AC guy and have them come out, check it out. When doing maintenance on systems, we typically look for signs that point to high static pressure, and we'll check the static pressure while we're there. But it's just I guess a good thing to know about. And if you're getting your system changed out, make sure that you ask them if they'll do a static pressure test when they fire the new system up, because every unit will operate a little bit differently from one manufacturer to the other. There might be 20, 40 CFM that is no longer there, or it may add 20, 40, 60, 100 CFM compared to the old system. So kind of just a thing to keep in mind. It isn't anything that you as a homeowner is going to be able to go check and address most likely, but it's something to be aware of to help keep your energy bills down, as well as preserve your equipment and make sure that it lasts as long as it can. But that's really all I've got for that today. I appreciate you all stopping by, and we'll catch you next time.